Hello everyone, welcome to SPECTROPY. Today's session I am going to explain about an atom. Okay, here what is an atom? Before introducing the topic atom, so in our daily life we see different types of materials and things which are present around us. So already you have studied in the 6th, 7th classes about matter. Do you remember? So here matter is nothing but, okay, suppose in a classroom, okay, the things which are present, those we call it as matter. Let us take an example, this stylus. It is an example of the matter. So in a classroom, this stylus or a board, it is going to occupy space and has mass. Some amount of weight is there, right? So this is called as matter. Then what is mean by an atom? What is an atom? So here atom is a smallest particle of the matter. It is the smallest particle of matter. So that smallest particle, can we divide? Can we break into two? No, right? So atom is indivisible. Atom is the smallest particle of matter, so where it is indivisible. But this atom consists of three subatomic particles. Three subatomic particles. Those are nothing but protons, neutrons and electrons. So these three are called as subatomic particles. Okay, now here what is the charge of electron? The charge of electron is negative and the charge of proton is positive. There is no charge for the neutron. So these three are called as subatomic particles. These three are called as subatomic particles, and the charges of three particles are electrons, there is a negative charge, protons, positive charge, and neutrons, there is no charge. So these three are called as subatomic particles. Based upon the subatomic particles, we are going to represent an atom. An atom. Suppose, let us take X is an element. X is an element. So here, always, okay, an element, okay, it consists of, atom consists of three subatomic particles, electron, proton, neutrons. Let us take, this is an atom. Okay, this is an atom. At the center of the atom, there is a nucleus. There is nucleus. So here, this atom consists of three subatomic particles, and these subatomic particles, how they are located in the atom, that we are going to see now. So here you can see electrons, neutrons and protons. Always electrons revolve round the nucleus. Electrons are going to revolve round the nucleus, whereas protons and neutrons are present inside the nucleus. Protons and neutrons are present inside the nucleus. So here I told you X is an element. X is an element. Based upon the subatomic particles, we are going to tell about the atomic number and the mass number. What is atomic number? Atomic number and mass number. What is atomic number and what is mass number? So here X is an element. Always atomic number is written at the bottom of the element and it is represented as Z, capital Z. And the mass number is represented as capital A. Okay, so here atomic number. What is the definition of the atomic number? Here atomic number is nothing but the number of electrons or the number of protons present in the nucleus. Present in the nucleus. That is called as the atomic number. And coming to the mass number, the number of protons and neutrons present inside the nucleus, that is called as the mass number. So how we are going to locate how these electrons, protons and neutrons, how these are placing in an atom, that I am going to show now. Okay, now you can see this is X. X is an element. So if I add, okay, I am going to take one proton. Okay, let us take, if I am going to take proton, so proton is placed inside the nucleus and one electron. So electrons are going to revolve around the nucleus. If I am taking proton, immediately you got the element name, that is hydrogen. Okay, so one proton and one electron is present. Then what about neutron? If I am going to add a neutron, whether it is stable or unstable. Now you got here neutral atom, right? Hydrogen. Okay, hydrogen is a neutral atom. If it is a neutral atom, then we call it as a stable element. We call it as a stable element. So here you can observe hydrogen atom consists. What is the representation now? This is X is an element, nothing but hydrogen is an element. The atomic number, what is an atomic number? The number of protons or electrons present in the nucleus is called as the atomic number. Now tell me, how many electrons or protons are present? Is it one or not? There are one proton. Okay, one proton. And what is the mass number? Generally mass number, if I remove this one, if I remove the neutron, it is stable. It is a stable. So how many electrons and protons are present now? Hydrogen, one electron or one proton, and in the center of the nucleus there is one proton. Okay, so this is called as atomic number and this is called as the mass number. Let us take one more example. If I take one more proton, when I am going to add, immediately you can see the element name helium, right? So is it unstable or stable? So it is unstable. Why it is unstable? There are two protons and number of electrons are how many? Only one. So what I told, atomic number is nothing but it should be number of electrons and protons should be same. So but here we have two protons. Okay, but what about the electrons? We have only one. So now I am going to add one electron. Again it is unstable. To become stable, it is a neutral atom but it is unstable. To attain the stability, now I am going to add one neutron. Now it became stable. Let us take one more neutron. Okay, it is also stable. Let us take one more neutron. Now again it became unstable. If I remove one neutron, now how many protons and neutrons are present here? How many protons and neutrons are present here? What is the symbol of that element? He is the helium, symbol of an element. Now what is the atomic number? How many protons or electrons are present? 2 electrons and 2 protons are present, right? So the atomic number will be 2. And coming to the mass number, how many protons and neutrons are present? 2 protons, 2 neutrons. Now mass number, what is the definition of the mass number? The number of protons and neutrons present in the nucleus is called as the mass number. Now how many protons or neutrons are present inside the nucleus? 2 neutrons, 2 protons, 2 plus 2, 4. Now the mass number of helium is 4. Now you can see here, this is the periodic table. Okay, the stability. This is about the stability. Suppose let us take one more proton. Again it became unstable. If I add one more electron, also it is unstable. Then if I am going to add one neutron, okay, it became stable. Let us take one more neutron. It became stable. If I add one more neutron, then again it is becoming unstable. Then remove the neutron atom. Now it is stable and it is a neutral atom. So you can see here, number of electrons, how many? 3. Number of protons, how many? 3. Whereas coming to the number of neutrons, how many are there? 4. So here, if we see, the symbol of lithium is Li. Symbol of lithium is Li. And the atomic number of lithium, how many electrons or protons are present here? 3, right? There are 3 protons or 3 electrons. So the atomic number will be 3. Coming to the mass number. What is the mass number? The number of protons and neutrons present inside the nucleus is called as the mass number. So now count how many protons and neutrons are present. 1, 2, 3, 4, 5, 6, 7. There are 7. Together we got 7. That 7 is called as the mass number. 7 is called as the mass number. So in this way we are going to represent an atom, how the subatomic particles are placed in an atom. Okay, so this is about the atom, number of protons, electrons and neutrons, how it is attaining stability. If suppose if I am going to remove one electron, okay, by removing one electron you can see here it is going to form an ion. So what is ion here? How it is going to form an ion? Suppose an element by losing one electron, here we are removing one electron, right? So that is nothing but electron is lost. When an electron is lost, so it is going to get positive charge. Clear? Okay, electron is lost. Okay, I added one electron and I am going to add one more electron. Immediately the charge is changed. By gaining one electron, it is getting negative charge. If I remove the electron, then it is getting positive charge. So when an element, when it is losing one electron from an atom, so it is getting positive charge. When an element is going to gain the electron, then the charge is changed to negative. If I am going to add one electron, it became stable. By adding, what is the charge of lithium now? Li minus. Gaining one electron. By gaining, it is getting negative charge, and by losing, it is getting positive charge. So this is about an atom. So now you can see the periodic table. This periodic table consists of different elements and how these symbols are given. So you know the elements like hydrogen, helium, lithium, beryllium, boron. So we are reading in this way. How the symbols, how we are going to give the symbol of an element. Symbol of an element. So let us take, that is, if I am going to take one proton, okay, immediately you can see here hydrogen is formed. Only one proton is there. There is no electron. When I add one electron, then it is going to become neutral atom. So you can see here the symbol of hydrogen is H, capital H. Always the symbol of an element is given by the first letter. The first letter of an element is nothing but the symbol of an element. If suppose, let us take hydrogen and helium. These two are elements. You can see here hydrogen and helium. These two are elements. Just now I told you the symbol of an element, we are going to take the first letter. If I take the first letter, that is hydrogen, symbol will be H, capital H. If I take the helium, the first letter is same. In both the cases, hydrogen and helium, both are starting with the same letter. If it is going to start with the same letter, then we are going to take the second letter as a symbol of the helium. Right. So here hydrogen and helium, both are starting with the first letter hydrogen. Right. So both are same. In order to differentiate, we are going to take the second letter as a symbol of the element. Always the first letter should be start with capital and the second letter should be taken as small letter. Right. This is the first method how to give the symbol of an element. Few of the elements, the symbol is given based on the Latin names. Okay, depending upon the Latin names also, they have given the symbol of the element. Let us take the example, that is sodium. Okay, what is the symbol of the sodium here? What is the symbol of sodium? Just now I told you symbol of an element is taken as the first letter or the second letter. But here the symbol of sodium is actually Na. Why they have taken as Na? What is the reason? That is depending upon the Latin name. The Latin name of sodium is natrium. The Latin name of sodium is natrium. So the first two letters of the sodium natrium is Na. So this Na is the symbol of the sodium. So few of the elements, the symbol is given based upon the Latin names. So here the symbol of an element was given in the periodic table based upon the first letter. If the first two letter of the two elements are same, then we are going with the second letter, and few of the elements symbol was given based upon the Latin names after the scientist name, countries and laboratories, and planet names. Few of the elements symbols was given based upon the planet names also, that is Neptune, Plutonium, like that. So you can see here there are different types of elements in this periodic table. The vertical, you can see the periodic table how it is, all are vertical groups and horizontal rows. So here in this class I introduced about the atom and the symbol of an element. So in the next class I will discuss how we are going to calculate the atomic weight of an element. Just now I told you by increasing this one. Okay, if I am going to add one neutron, okay, neutron, when you see it is an unstable. If I take one electron, also it is unstable. So if two electrons are there, then two protons should be there inside the nucleus. It should be equal. Now it became stable and it is a neutral atom. If suppose I am removing one electron, immediately what is the charge you are getting here? Positive. If I am going to add one electron, what is the charge here you are getting? That is negative charge. So this is about the symbol of an element and an atom. Next is what is meant by a valency. What is the valency? So here valency is nothing but, just now I told you, a combining capacity of an element is called as the valency. Here why an element is going to combine with another element. What is the reason? What is the reason? Just now we are seeing, see here, when I remove, immediately it is going to form neutral atom and stable, right? This stable is nothing but what? An atom he is having stable, it is attaining stability. Stability is nothing but it which is having 8 electrons in the outermost shell, then we call it as a stable element. So here valency is nothing but the combining capacity of an element is called as an valency. So few of the elements in the periodic table, those are unstable. You can see this last column, helium, neon, argon, krypton, xenon, radon, these elements are stable in the periodic table. That is the reason there is no need to lose or gain. There is no need to combine with another element. Remaining all elements in the periodic table are unstable. Due to that reason, few of the elements loses the electrons and few of the elements gains the electrons. Okay, so that is called as an valency. Whenever an atom loses the electrons, it is going to get positive charge. When an atom going to gain the electron, then it is going to get negative charge. So this is the basic introduction of the atom. So in the next class, I am going to teach the basic what is a valency, how we are going to get charge, what is how outermost shell, and which is one is the inner shell. That I am going to explain in the next class. Okay, thank you all of you.